Imagine you're a tank crewman in the 1950s. Your government just assigned you to a new experimental vehicle. You climb inside and notice something strange. There's a nuclear reactor right next to you, in the tank, with the ammunition. Your commanding officer smiles and says, "Don't worry, you'll only be irradiated for a few weeks before we rotate you out." This isn't science fiction. This is the Chrysler TV-8, America's attempt to build a nuclear-powered tank during the Cold War. Today I'm going to tell you about one of the most spectacularly stupid military designs in history. A tank so dangerous that it would kill its own crew before it ever saw combat. A vehicle that combined the safety of Chernobyl with the practicality of driving a bomb into battle. This is the story of how Cold War paranoia, unlimited budgets, and engineers with zero common sense almost created mobile nuclear disasters. Let's talk about the tank that would have turned every battlefield into a radiation zone. Chapter 1. Cold War Paranoia, the Context. To understand why anyone thought nuclear tanks were a good idea, you need to see how paranoid America was in the 1950s. Because this wasn't just one crazy engineer's fever dream. This was official military policy backed by millions of dollars. 1950s. The Cold War is heating up. The Soviet Union has nuclear weapons. America has nuclear weapons. Everyone's terrified of everyone else. And the American military has one obsession: put nuclear power in everything. Nuclear submarines? Already building them. Nuclear aircraft carriers? In development. Nuclear bombers? Working on it. Nuclear missiles? Obviously. And then someone asks, what about nuclear tanks? The logic seemed sound at first. Traditional tanks run on diesel or gasoline. They need constant refueling. Supply lines are vulnerable. Fuel trucks can be attacked. But a nuclear-powered tank? It could run for months, maybe years without refueling. No supply lines to protect, no vulnerable fuel depots, just pure, unlimited atomic power. If you're thinking this sounds like putting a nuclear reactor on wheels and driving it into combat, congratulations, you're smarter than the entire U.S. Army Procurement Department in 1955. The Army puts out a request: we want nuclear-powered tanks. Multiple companies compete for the contract. Chrysler, yes, the car company, decides to enter the competition. They proposed the TV-8. TV stood for test vehicle. The 8 meant it was their 8th design concept. And the design was absolutely insane. Because Chrysler didn't just put a nuclear reactor in a tank, they created a vehicle that solved the problem of how do we kill enemy soldiers by first killing its own crew. Chapter 2. The Design. Engineering Madness. There are bad tank designs. And then there's putting a nuclear reactor in an egg-shaped turret with the crew and ammunition. Because every single design decision made this tank more dangerous to its own operators than to the enemy. The Chrysler TV-8 looked like something from a science fiction movie, and not a good one. The hull was relatively conventional: tracked vehicle, armor plating, standard tank stuff. But the turret, oh, the turret! It was shaped like a giant egg, about 3 meters tall. And inside this egg, Chrysler crammed a small nuclear reactor, the entire crew, 4 to 5 men, all the ammunition, the gun systems, and control systems. Let me repeat that. The nuclear reactor sat in the same compartment as the humans and the explosives. It's like designing a car where the engine is in the passenger seat and the gas tank is in your lap. The nuclear reactor was supposed to be a small, compact design, about the size of a large refrigerator. It would generate heat. That heat would create steam. Steam would power turbines. Turbines would drive the tank. In theory, the tank could operate for 300 to 500 hours without refueling the reactor. That's weeks of continuous operation. But there were some tiny problems, minor issues really. Problem 1. Radiation shielding. To properly shield the nuclear reactor, you need thick layers of lead, concrete, and other materials. That's why nuclear power plants have massive containment buildings. But tanks need to be mobile. They can't weigh 1,000 tons. So Chrysler's solution? Minimal shielding. Just enough to maybe, possibly, hopefully reduce radiation to survivable levels. Survivable here means you probably won't die immediately. Problem 2, heat. Nuclear reactors generate enormous amounts of heat. That's the whole point. Use the heat to create steam. But you're sitting inside a metal box with a heat source that operates at hundreds of degrees in the summer, possibly in a desert. The crew compartment would be like a sauna, except instead of relaxing, you're slowly being cooked and irradiated. Problem 3. What happens if you get hit? Traditional tanks carry diesel fuel. If the fuel tank is penetrated, you get a fire. Bad, but survivable if you evacuate quickly. The TV-8 carried a nuclear reactor. If enemy fire penetrated the turret, which contains the reactor, the crew, and the ammunition, you'd get potential ammunition explosion, nuclear damage, radiation leak, dead crew, and contaminated battlefield. Chrysler's official documents acknowledged this. They literally wrote, "Crew exposure to radiation will require periodic rotation of personnel." Translation? Your tank will give you cancer, so we'll swap you out every few weeks for fresh victims. And the best part? The military seriously considered building this thing. Chapter 3. The Radiation Problem. Slow Death on Tracks. When you put humans next to a nuclear reactor with minimal shielding, bad things happen. Because this wasn't a theoretical problem, the math was clear. Operating this tank would slowly kill its crew. Let's talk about radiation exposure. The human body can handle small amounts of radiation. We're exposed to it naturally from the sun, rocks, even bananas. But nuclear reactors produce serious radiation, gamma rays, neutrons, the kind of radiation that damages your DNA and causes cancer. Chrysler knew this. They calculated the radiation exposure for the crew. Their own estimates, crew members would receive radiation doses that exceeded safe limits within weeks of operation. The solution? Rotate crew members frequently. Use them for a few weeks, then swap them out for new ones who haven't been irradiated yet. This is the military-industrial complex version of the solution to pollution is dilution. Can't make the reactor safe? Just rotate through more soldiers. Problem solved. Except it's not solved. You're just spreading the cancer around to more people. And this assumes the reactor operates normally. What about maintenance? Someone has to service the reactor, check the systems, replace components. That person would receive massive radiation doses. Chrysler's solution? Use personnel specifically trained for high radiation environments. Translation? Some poor bastard in a radiation suit will do it, and he'll probably get cancer. But wait, it gets better. Remember, the ammunition is stored in the same compartment as the reactor. Ammunition doesn't like heat. High temperatures can cause propellant to degrade or even ignite spontaneously. So you have a heat source, reactor, explosives, ammunition, humans, crew, all in one small metal egg. This is like storing fireworks in your oven while it's on, while sitting in the oven, while the oven is also radioactive. But the absolute worst-case scenario wasn't crew radiation exposure. It was what happened if this tank got destroyed in battle. Chapter 4. Battlefield Chernobyl. The worst-case scenario.
When a normal tank gets destroyed, you get fire and explosions. When a nuclear tank gets destroyed, you get something much worse. Because every TV-8 destroyed in combat would create a permanent radiation hazard on the battlefield. Here's what happens when you destroy a conventional tank. Enemy hits it with armor-piercing round, round penetrates armor, fuel ignites, ammunition cooks off, big explosion, fire burns out, tank is destroyed. Dangerous for the crew, obviously, but once the fire burns out, the wreck is just metal. You can salvage it, push it aside, or ignore it. Now let's talk about destroying a TV-8. Enemy hits the turret. Round penetrates the egg-shaped armor, hits the reactor containment. The reactor itself won't explode like a nuclear bomb. That's not how reactors work. You need very specific conditions for a nuclear explosion. But what will happen is a radiation leak. And by leak, I mean catastrophic release of radioactive material across the battlefield. The reactor core contains radioactive fuel. If the containment is breached, this material is exposed. If there's a fire, and there probably will be because ammunition is exploding, the heat can vaporize some of the radioactive material. This creates radioactive smoke, radioactive particles in the air, radioactive contamination on the ground. Anyone near the destroyed tank gets irradiated. Your own troops, enemy troops, civilians, everyone. And it doesn't go away. A conventional destroyed tank is dangerous for a few hours while it burns. Then it's just scrap metal. A destroyed TV-8 would be a radiation hazard for decades. The immediate area would be contaminated. Soil, water, vegetation, all radioactive. You couldn't safely occupy that ground, couldn't use it for agriculture, couldn't let civilians return. Every destroyed nuclear tank would create a mini exclusion zone, like Chernobyl, but on a battlefield. Imagine the tactical implications. General, take that hill. Soldier, sir, there's a destroyed nuclear tank there from last week's battle. General, oh, never mind then. That hill is cancer now. And this assumes the reactor is properly contained before being hit. What about reactors that malfunction during operation? Chrysler's design had no real plan for reactor accidents in the field. If the reactor starts to melt down while the tank is operating, what do? Abandon it? Now you have an uncontrolled reactor on the battlefield. Try to fix it? The crew is already being irradiated. A malfunction makes it worse. The more you think about this design, the worse it gets, which is probably why the military eventually came to their senses. Chapter 5. The Death of a Bad Idea. Sometimes projects die because they're too expensive. Sometimes because even the military realizes this will kill everyone. The TV-8's cancellation was the moment America started questioning whether nuclear power belonged in everything. The TV-8 never got past the design phase. No prototype was built, no crew was irradiated. But not because it was immediately canceled as insane. No, the TV-8 competed with other nuclear tank designs for years. Ford had one, General Motors had one, several defense contractors submitted proposals. Throughout the late 1950s, the Army seriously evaluated these designs, spent millions on studies, held meetings. This is what happens when you give the military unlimited budgets and tell them to think big. They think so big, they forget practical or safe. What finally killed nuclear tank programs wasn't common sense. It was a combination of factors. Weight was unsolvable. Even with minimal shielding, reactors were too heavy, over 50 tons, extremely heavy for that era. Heavy tanks sink in mud, can't cross bridges, have limited mobility. Cost was astronomical, hundreds of millions of 1950s dollars, equivalent to billions today. For that price, you could build hundreds of conventional tanks. International politics mattered too.
NATO allies asked, "Wait, you want to drive radioactive tanks through our countries?" Better alternatives emerged. Gas turbine engines offered better power-to-weight ratios. Conventional solutions could meet range requirements without radiation problems. And someone finally asked, what problem does this actually solve? Fuel supply for tanks wasn't that critical. Supply lines worked. One anti-tank round through the reactor created bigger problems than running out of diesel. By 1963, all nuclear tank programs were quietly terminated. Chrysler went back to making cars. The Army invested in conventional tanks. The M60 Patton, later the M1 Abrams with its gas turbine. These tanks worked, didn't irradiate crews, didn't contaminate battlefields, were actually practical. But the TV-8 wasn't the only insane nuclear project. It was one of many examples of nuclear paranoia gone mad. Final act, the nuclear madness era. The TV-8 wasn't isolated insanity. It was part of a larger pattern. Understanding the TV-8 means understanding how Cold War paranoia made an entire generation of engineers lose their minds. The 1950s were peak put nuclear power in everything era. The mentality, nuclear power is the future. Nuclear power will win the Cold War. So they tried to nuclearize everything. Nuclear-powered aircraft. The Air Force spent over $1 billion developing a nuclear bomber. The idea, stay airborne for weeks without refueling. The problem, radiation shielding was so heavy the plane could barely fly. Canceled in 1961. Project Pluto, a nuclear-powered cruise missile. Unlimited range. The problem, it left a trail of radioactive exhaust wherever it flew, designed to irradiate everything below before hitting its target. Canceled because even the military realized this was biological warfare disguised as a missile. Project Plowshare, using nuclear bombs for civilian construction, dig canals with nukes, excavate harbors with nukes. They detonated 27 nuclear devices for peaceful purposes before realizing radioactive canals weren't useful. The pattern is clear. Just because you can put a nuclear reactor in something doesn't mean you should. Some nuclear projects worked, submarines and carriers, but these worked because crews are separated from reactors by proper shielding, ship size allows heavy radiation protection, and tactical advantages are real. The TV-8 had none of these. The TV-8 represents the peak of Cold War nuclear insanity. It combined every problem: radiation exposure, battlefield contamination, massive cost, minimal tactical advantage, danger to friendly forces, all to solve a problem, fuel supply, that wasn't actually critical. The TV-8 failed because engineers fell in love with technology without asking whether it solved a real problem. Thankfully, someone eventually asked, "Should we do this?" and said, "No." The TV-8 never irradiated a single soldier, never existed except on paper. That's the best possible outcome for one of history's worst military designs. Conclusion. So that's the Chrysler TV-8, the nuclear tank that would have turned battlefields into radiation zones. A design so dangerous it would have been more effective against your own army than the enemy. A vehicle that combined tank mobility with Chernobyl's safety profile. It's a reminder that Cold War paranoia led to genuinely insane proposals, that unlimited budgets don't mean unlimited sense, and that sometimes the best decision is to not build the thing. If you enjoyed this story about Cold War nuclear madness, check out the next video. Leave a comment. What's the most insane Cold War military project you've heard of? See you next time, where hopefully we'll discuss weapons that don't require rotating crews due to cancer risk.